Hello everyone, this is lab 7, that is on implicit plots and tangent lines. So this lab is again not as difficult as the previous labs because all the commands that we have seen is very familiar to all of us, and this lab is again it's very short compared to the previous labs, but you may have to do a little bit of paperwork, uh, and that's not that hard as well. So before we actually start, i I honestly and highly recommend for all of you to practice problems on implicit differentiations, how to take implicit derivatives. So let's say I have no access to writing material, so I just have to say through words. So kindly focus on whatever I say and listen very carefully. Okay, so this lab is all about implicit derivatives. So if you uh, correctly find implicit derivatives, the lab is done. Okay, so let's say you need to plot a tangent line to the circle. Now x squared plus y squared is equal to 1. So this is an equation for a circle of radius 1. Okay, I repeat, this is an equation for a circle of radius 1. Okay, this is a square r square, so square root of 1 is again 1. And you have to plot a tangent at these points. So this is x point and that is y point, x comma y. So you are fixing a point and you are asked to find a tangent for a circle of radius 1. Okay, now to find a tangent, as usual, we need to know the slope and then the tangent equation. Of course, we have seen this earlier. Okay, so as I told you before that we have to take implicit derivatives. So derivative of x squared is 2x, correct, plus derivative of y squared is 2y times dy, that is equal to 0 because derivative of 1 is 0. Now I'm going to repeat that. It is 2x plus 2y times dy over dx, which is equal to 1. Now I'm going to send this 2x to the right hand side with a negative sign, and I have two zeros, two's cancelling out there. I'm going to show you to here. So I have x squared plus y squared, which is equal to 1. So when you take implicit derivatives, it is 2 times x plus 2 times y. Now when we have implicit derivatives, we must not forget that we are taking derivative of y with respect to x. So it is dy over dx, which is equal to 0. Now rearrange this equation. If you rearrange this equation, you will have that function. So dy over dx is equal to negative x over y. Now remember, when you take the derivative of a function, it is slope. Okay, it is absolutely slope. Now there are quite a few things that you must look at very carefully, so please look at it. Okay, so the slope is done. Now we have 2 points. Now this is x1 and that is y1. Remember to have these points just like that, x1 and y1, and do not make a mistake of having x and y's instead of x1 and y1, because you are already using x and y there. So you have to find some other suitable way to rename that variables. So that's the reason I have x1 for x point and y1 for y point. Now you need to find slope of that points, right? You need to find slope of that points. So that is why we know this dy over dx is slope. So I'm going to call that as m. M is equal to negative x1 over y1. Okay, so as soon as you take the implicit derivatives and get an equation for dy over dx, which is m, you have to replace all your x to x1s and all your y's to y1s. Okay, just make sure that you do this. Okay, so all your x will become x1s and all your y's will become y1s to find slopes. Okay, so x1 y1 are the points. To find slopes, you are going to use the same points to find slope. Okay, Now let's go back to our MATLAB file. So that's what I've done here. These two are the points where I need to plot a tangent and also find slope. Of course, I need to find slope and then plot a tangent. So those two are the points, x1 and y1. That is the equation I have. So my slope is the implicit derivative of that equation, of the given equation, dy over dx. So I need to find slope at that point. So I'm going to say negative x1 over y1, which is negative 1. Now define the variables x and y, because we have x and y being used here. And then equation 1 is nothing but you rearrange this equation such a way that you have 0 on the right hand side. Okay, so you have x squared plus y squared is equal to 1. So I'm going to transfer this 1. I'm subtracting 1 on both the sides. So if I subtract 1 on both the sides, I have x squared plus y squared minus 1 is equal to 0. So that is what I have. So make sure you are rearranging the equation such a way that there is a 0 on the right hand side, which means you're transferring all the data which is on right hand side to the left hand side, okay, leaving behind a 0 on right hand side. So that is your equation. Now you need to plot tangent. We know this equation, we have used this, there's nothing to change. So we'll use the same equation every time. So m times x minus x1 plus y1 minus y. Remember, we have a tangent equation as y is equal to m times x minus x1 plus y1. Since we are transferring all the data which is on right hand side to the left hand side, leaving behind the 0, that is why we have negative y there. Okay, that's the tangent line, there's nothing to change. Now we need to plot the equation. As soon as I plot that equation, I should see a circle, right? Equation 1, if I plot equation 1, I should see a circle of radius 1. I can clearly see that. Now hold on, because I need to plot tangent as well, so I need to hold on. Now scatter x1 and y1. Now what does this command do is, it's going to create a little circle where we are focusing on. So we are focusing on, remember, we are focusing at square root of 2 over 2 comma square root of 2 over 2. So x-axis, x value is square root of 2 over 2, somewhere there, and y-axis is square root of 2 over 2, so somewhere there. So it's going to mark that point. Now I need to plot tangent line. We know what a tangent line is, so kindly plot tangent line just like the way it's done here. Now title, we have seen this command, so your name goes here with the date. So you have to simply change your names here and the date. So it's going to name that file. So that's what you have to do on this lab. So as far as assignment is concerned, you have to take implicit derivatives of this equation. Okay, so equation 1, what we had here, equation 1 is simply that. You know why? Because we already have a 0 on the right hand side. So you simply have to have this equation as equation 1. So I'll tell you where you have to change things. You have to change x1 and y1 with square root of 3 over 2 plus 1 to square root of 3 plus 3 over 2. So this is x1, that is y1. And also you have to change your m. Where do you get m from? You have to take implicit derivatives with respect to x and y. So take the implicit derivatives of this function and get an equation for dy over dx. Okay, so here you will have to use product rule. Here also you will have to use product rule. Wherever you see x and y together, of course you have to use product rule because it is implicit derivatives and both are function of itself. So kindly practice few problems on how to take implicit derivatives and then get on to this part of the problem, because without implicit derivatives it's not going to be easy. So you have to change m. So when you are having implicit derivatives of the given equation, you have to change all your x to x1 and all your y's to y1, because you need to find slope at the given points x1 and y1. Okay, do not make a mistake of having x and y's in the equation m. Okay, make sure that you're changing to x1s and y1s to find the slopes at a given point x1 and y1. Then everything remains the same. So you have to define two variables. Then you have to have an equation just like with a 0 on the right hand side. So just like this, you have to have an equation just like that. So here sine of x plus y is equal to y squared cosine of x. So you have to transfer this entire function to the other side. So subtract y square times cosine x on both the sides. So you will have sine of x plus y minus y squared cosine of x is equal to 0. So just like that. Then everything remains the same. So you just have to use the same equation for tangent line. Your equation would be changing, of course, yes. So plot the equation, scatter, yeah, nothing is going to change here. Yeah, this lab is all about implicit derivatives, so I highly recommend you to practice few problems on how to take implicit derivatives, and this whole lab is going to be super easy. Okay, then see you next class. Thank you.